we're going to look at the difference between sets and interval notation. And it's subtle in the way that it looks. One thing could be written like this, and the other thing might be written like this. Okay, those differences there in this symbol, whether it's a brace with those curly cues or a bracket, it makes a really big difference in math, okay? On our number line, when you have the curly cues, you just have two things, just the numbers 1 and the numbers 3, and that's it, nothing else, okay? Now, if you have those brackets, it's actually an infinite number. It goes from 1 and then 1.11, 1.112, every single possible number, and there's an infinite number of numbers between 1 and 3. All right, now the other thing that can be written is with a parenthesis, 1 comma 3, and that means it's still interval. So these are both intervals. These on this side, this is interval, so it's an infinite number of things that are contained within that section. It's just that between our 1 and a 3, everything's included except we're not including 1, we're not including 3. So it's just those numbers in between, and we can show that by shading in between those two open circles. Okay, and this one has closed circle, and we're just shading in between those two closed circles because this would be everything that is less than or equal to 3 and greater than or equal to 1, and this one is not including 3, not including 1. And I also just want to show you that sometimes that graph can be written in a little bit different way, where instead of a closed circle, you'll see a bracket when it's including those endpoints, and then there's shade in between there. And then sometimes instead of an open circle, you'll see a parentheses. It's just a little bit easier to type this, actually. The open circle, closed circle is really hard to type. So sometimes you'll see that. So parentheses is when it's just less than or greater than, and a bracket is when it's less than or equal to, greater than or equal to. Okay, so interval notation represents an infinite number of values between two endpoints, and set, this is set notation, and set notation is a list of elements. All right, so let's look at this. We have y is negative, so there's a whole bunch of possible answers there, and we want to show that by saying everything less than 0. And graphing that, it would look like here's 0, and I would do a parentheses and shade, or if you like that open circle, that's great too. Both of those mean the same thing. And now in terms of this other thing, interval notation, so that is just showing the endpoints. With interval notation, we go from left to right, and we're looking at the endpoints, and we either have parentheses or brackets, the smaller number, comma, the larger number. Okay, so the order matters a lot. The parentheses we use for greater than or less than. The brackets we use for greater than or equal to, less than or equal to. And in terms of open circle, the graph would look like this, and then with the brackets, it would be closed circles. Okay, so that's a little thing for interval notation. It's just a really compact, easy way to type an answer and represent the graph. Okay, so number lines go from negative infinity to infinity, and we're going to use a parenthesis because that is not including 0. There's no equal there. So we use a parenthesis at 0, and then we're going from negative infinity as the smaller endpoint to 0 is the larger endpoint. So we go from left to right on the number line, and then for infinity and negative infinity, we always use a parenthesis. Okay, let's try another one. Z is greater than 3. So not including 3. So I have 3. You can use a parentheses there or open circle. Either one is great. Okay, and then in terms of interval notation, I would have my smaller number, The endpoint there is 3. Use a parenthesis because we're not including 3 in our solutions. And then we head off towards infinity. Okay, b is at most 6. So b can be equal to 6. It can't be 7, it can't be 8, so it's everything equal to or less than 6. And here's 6. I could have a closed circle, everything less than, or if you like that bracket, that's great too. Okay, and then interval notation from negative infinity to 6, and use a bracket on that 6 because of our equal. W is positive and is less than or equal to 14. Okay, so if we're at 0, it's positive, and then less than or equal to 14. So we're going up to 14 and including it. Oh, I could have an open circle there. Okay. Or you can just do your parenthesis and bracket. So it's positive, so it's greater than 0. So it goes from 0, it's greater than 0, or less than or equal to 14. So there would be my interval notation, or sorry, there's my inequality, and then interval notation is just a little snapshot of this graph. So it goes bigger than 0 with a parentheses, and then less than or equal to 14 with that bracket. Okay, great. So now let's look at sets. And we've looked at this a little bit. A set is just a list of elements. And let's see, if we have nothing in our set, if there's nothing in there, it's called the null set. And you can represent it with these, either just like a 0 with a line through it, or just those braces, those curly cues with nothing in it. That means the empty set. All right, and we have also is an element of, that's that kind of curly E looking thing, and then is not an element of would just be crossed out. If we want to say one, or it's part of one or the other or both, we use what's called the union, which is that U. And if we want to say it's both at the same time, then that would be an and or an intersection. So let me just show some examples here. Okay, so let's say that A is the set of, there's just 2 things in A, 2 numbers, 1 and 3. Okay, so is 2 contained within A? Nope, it's not. All right, now if we're finding the intersection of A and B, that means what's contained within both A and B. So if we look at A, we have 2 things, 1 and 3. And in B, we have 1 and 5. Okay, so this intersection is what's contained in both at the same time. Okay, so that would be just one element is contained within both at the same time, and that's the number 1. Okay, now this union, the or, is it could be contained within A or B or both. Okay, so the union is, this one is the intersection. They have to be contained within both at the same time, one and the other. Okay, the union is, there's 5, there's 1, there's 3, right? There's, okay, so that is, it's contained in both, it's contained in one or the other. So that would be everything. 1, 3, and 5. All right, let's look at the intersection, what's part of both A and C at the same time. So we need to have 1, but that's not contained here. 3 is not contained here. 0, nope. 2, nope. 4, nope. So there's nothing that's contained within both at the same time. So there's nothing in there. That would be the null or empty set. And I could have written that with a 0 with a line through it. That would also be a representation of the null set. All right, so let's look at just this other example with an and or an or. Okay, so let's say that we had a slightly different situation where W, it has to be negative, so it's less than 0. Okay, and it has to be greater than or equal to 14. There's nothing that's shaded that both of those happen at the same time. So this would be nothing. Nobody's coming to this party. Okay, so you can show that as an empty set. So you just have a 0 with a line through it, or you could write it actually this way as well. It's the set of nothing. Okay, so those are answers for if you have no solution, or it's what's called the null set of nothing. Okay, how about this one? You can be negative or greater than or equal to 14. Because of that or, everyone's coming who's less than 0. So all of you guys come on over. Oh, and it's a parenthesis here because it's just less than 0. Okay, or if you're greater than 14, you're coming. All right, so the or includes one, the other, or both, and has to be at both true at the same time. Moving on, now we're going to look at sets, and so there's this curly cues here. That just means the set of, and it's just a list. So in this case, A equals curly Q 1, 3. What that means is A is the set containing the numbers 1 and 3. Now if you have nothing in your set, in your list, then we would just have the null set, which is a big huge, it looks like a 0 with a line crossed off. Or you could have your bracket or your set notation with just nothing in it. So that also means the empty set or the null set. Okay, and this funny looking E means is an element in. If it's crossed off, it's not an element. Okay, and now this big U, that means we're putting them together, and you can have one or the other or both. And intersection means they have to both be true at the same time. So let's look at an example. Is 2 contained within, is it an element of A? And it's not, because all A has is just 1 and 2. Okay, now we're going to look at the intersection. So it has to be, these numbers have to be part of both A and B. So 1 is part of both A and B, but there's no other numbers that are part of both at the same time. So that is our and, which means it has to be part of both one and the other at the same time. Okay, now or, that's our U. It's much more inclusive. It's one or the other or both. So everything that's included in A, okay, and also anything that's included in B. We don't have to repeat and list the 1 twice. Now let's look at what's part of A and also C. So we're looking at 1, but that's not in here, and 3, it's not in here either. So since there's no number that's contained within both, that means that we have the null set, or just the empty set, and you could have also written that null set with a 0 with a line through it. Okay, so the big idea is that I think of that like a cookie cutter, like it has to be both. It's really super exact, both exactly the same. So it must be contained within set A and set B. Okay, now our or is much more inclusive. Okay, it could be set A or set B or both, so either one. All right, and then there's that really specific, it has to be contained within both, one and the other at the same time, and that one resulted in nothing, and we call that either the null set or it's the empty set. Okay, there we go. So there's a lot of math vocabulary. All right, so let's put both inequalities and the intersection and union together. So here we have that one, which is our or. Okay, the big U is our or. So it can either be contained within B or C or both. All right, so let's just visualize this. B is everything less than 5. So here's my 5. I can't be 5, but I can be everything less than. So there's my B. Okay, and now C is going from -1 to 6, and I can not equal -1. It's x, -1 is less than x, so x is not the same as -1, and then it goes up to, can be equal to 6. So either one or the other. So anything that is contained, it's basically like the shading, it's like either contained in C or in B. So even though C stops here, because it's that or, it's everything that's also contained in B. So it's everything going from -infinity up to 6, and that's including our 6. Okay, let's try the next one. This is an and. So it has to be basically double shade. So it has to be both of them at the same time. So we're going from -1 to 5 for, actually -1 to 6 for our C. -1 to 6. Okay, and then our A, or our B was going, everything is less than 5. So that was our B, and our C was -1 to 6 inclusive. So we need to have everything that's happening to both at the same time. So this would just go from -1 to 5. And both of those are going to have parentheses because we can't include, we're not included in our -1 because of the symbol right here. And we're not including our 5 because of that symbol right here. On this one, it's the same idea. It's just that our intervals were written, instead of as inequalities, they're written in interval notation. So let's check out and see what we've got here. So we've got from -1 to 4, and we're not including, those are both parentheses, so those are open circle at -1 and 4. And then our next one is from 0 to 6, and those are inclusive, so those are closed. Okay, so here I'm seeing my and symbol, so that means that it needs to happen at the same time. Okay, so that would be when they're both shaded. So and both, they're happening at the same time. So I'm going from 0 and including it up to 4, and that is not included. So we need a parentheses there. Okay, and now we have our or, which is much more inclusive. So it's one or the other, or they can happen at the same time, you know, one or both. One or the other or both. So basically that's just much more inclusive. We're looking at everything that's shaded on either one. So I'm going to go from -1 to 6.